Okay, ladies and gentlemen, let's talk about parallelograms. Now, what we're going to do is we're going to assume a parallelogram is a parallelogram. Now, remember, in a parallelogram, we can only say one thing. The definition is two sets of parallel, that's what the two vertical lines mean, sides in a quadrilateral. Okay, so that means this side is parallel to that side. That's what the little arrows mean. This side is parallel to this side. That's all you know for sure. Everything else we have to prove. That's why we have theorem 6.3 that says if we have a parallelogram here, 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 prove that opposite sides are congruent. So here we go, A, B, C, D. Now, to prove opposite sides are congruent, I'm actually going to need to prove some triangles. So I would start by drawing a line down the middle and say it's reflexive to itself. Now, the nice thing about that is I now have this cut by a transversal, which means I have this angle and this angle have to be congruent by alternate interior angles. So I have DB congruent to DB reflexive. I have angle ABD congruent to angle CDB by alternate interior angles, because if lines are parallel, then I can do alternate interior angles. That also means that I have these lines that are parallel because two sets of parallel sides. So this angle is congruent to this angle. So I can say angle ADB is congruent to angle CBD by alternate interior angles. And now I can say triangle ADB is congruent to triangle CBD by angle side angle. And now, if the triangles are congruent, so this whole triangle is congruent to this whole triangle, automatically I can say AD congruent to BC by CPCTC. So that's congruent to that. And I can say AB is congruent to DC by CPCTC. There we go, CPCTC. And so now I have proved that opposite sides are indeed congruent. Now let's move on to the next one. Again, we're given for theorem 6.4 that it is a parallelogram, A, B, C, D. And so that means that A, B, C, D is a parallelogram that is given. We know that AB parallel to DC and AD parallel to BC. That's by definition of parallelogram. Now, boom, 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 boom. Now, we want to prove that opposite angles are congruent or supplementary. So we want to prove opposite angles supplementary. Opposite angles supplementary. Now, the nice thing is I don't have to work very hard at this, because if this and this are parallel and this is a transversal, I can say this and this are supplementary. So I can say angle B supplementary to angle C by same side interior angles, also known as consecutive angles. Now, with that, I can also say that this angle over here is supplementary to this angle here by angle A sup to angle D by consecutive angles. I can also say, if I turn the picture this way and deal with those parallel lines cut by this transversal, A and B are supplementary. Angle A is supplementary to angle B, that is consecutive, and angle D is supplementary to angle C by consecutive. So we've worked our way all the way around the figure, and so now I can say angle A is congruent to angle C, and angle B is congruent to angle D by angles supplementary to the same angle are congruent. And there we go. We're using, again, our parallel lines. We're using the fact that we can move them around, that we can also use angle supplementary to the same angle must be congruent. Okay, then let's move on down. We already really covered 6.5 because we had to prove 6.5 to get to 6.4, at least in that direction. Now, we could have also, by the way, proved opposite angles congruent by doing the same two triangles that we did here. And once the triangles are congruent, these two angles have to be congruent. So we could go that direction. Now, if a parallelogram has one right angle, then it has four right angles. Well, let me actually steal this one back. And if I have all of this is true, and I know that angle D equals 90, then since D and C are supplementary, angle C has to equal 90 by substitution. So given by substitution. And if angle C is 90, well, wait a minute, angle B equals 90 by, again, substitution. And I can do angle A equals 90 by substitution. And so now I have a shape that has opposite sides parallel and four right angles. We can say that parallelogram ABCD is a rectangle by def of rectangle. There we go, by definition of rectangle. So we have through theorem 6.6. Now, we've already proven theorem 6.8 because theorem 6.8 says if I cut a diagonal, I make two congruent triangles. Well, we did that by saying reflexive, alternate interior, and then we said by angle side angle. So theorem 6.8 is also proved right up here by the triangles. And once I have the triangles congruent, then I can prove that the diagonals bisect each other, and that becomes important as well. So we have all sorts of proofs, but they all come back to one idea, that a parallelogram is nothing more than two sets of parallel sides. Once I know that, I can start talking about their angles, and once I start talking about the angles, then I can prove triangles, and once I can do those two things, I can say pretty much all the different pieces do all the different things. So let's take a look from there.